December 6th, 2013. 60 feet beneath downtown Seattle. The largest tunnel boring machine ever built stops moving. 1,083 feet into a 9,270-foot journey. 11%. The crew notices the cutter head rotating, but no longer catching soil. Metal fragments appear on the conveyor belt. Then the machine overheats, and they shut it down. It will not move again for 2 years. The obstruction that stopped a 57.5-foot diameter, 6,700-ton machine built by one of the most experienced tunnel boring firms on Earth was an 8-inch steel pipe. The pipe was installed by the same agency that hired the machine. Its location was in the project documents the entire time. This is the story of Bertha. February 28, 2001. The Nisqually earthquake hits the Puget Sound region, a magnitude 6.8 quake centered 60 miles south of Seattle. The shaking damages hundreds of buildings, cracks bridges, and buckles infrastructure across the city. The worst casualty is the Alaskan Way Viaduct, a double-deck elevated freeway running 2 miles along Seattle's waterfront. Built between 1949 and 1953, the viaduct carried 100,000 vehicles a day on State Route 99. After the quake, engineers determined the structure was seismically compromised. It had survived this earthquake, but it might not survive the next one. The city, the county, and the state spent 8 years arguing over what to do. A rebuilt elevated highway, a surface boulevard, a cut-and-cover tunnel. More than 75 alternatives were studied. In January 2009, Governor Christine Gregoire, King County Executive Ron Sims, and Seattle Mayor Greg Nickels announced the decision. It was for a deep-bored tunnel, 1.7 miles beneath downtown Seattle. The plan called for a double-deck highway inside a single bore, 4 lanes of traffic stacked 2 over 2. The estimated cost was $3.1 billion. Nothing this large had ever been attempted under an American city. The project needed a tunnel-boring machine unlike anything in existence. A typical subway tunnel uses a machine about 21 feet in diameter. This tunnel required 57.5 feet. The face area was 7 times larger than a standard subway bore. Every ring of excavation removed roughly 1,000 tons of soil, the equivalent of 30 truckloads. The Washington State Department of Transportation selected Seattle Tunnel Partners, a joint venture of Dragados USA and Tutor Perini Corporation, as the design-build contractor under a $1.35 billion contract. Seattle Tunnel Partners chose Hitachi Zosen Sakai Works in Osaka, Japan, to build the machine. Hitachi Zosen had delivered more than 1,000 tunnel-boring machines worldwide, but none this big. The machine cost $80 million. It was 326 feet long. It weighed nearly 7,000 tons. It stood 5 stories tall. It carried restrooms, a kitchen, and a control room. The crew numbered 25. The cutter head alone weighed 944 tons and held roughly 700 cutting tools in 3 types. One set ground soft soils. Another pulled material into the screw conveyor. A third handled harder ground. The machine was an earth pressure balanced tunnel boring machine, meaning it used the excavated soil itself to stabilize pressure at the cutting face, preventing the ground above from collapsing. Bertha left Osaka Harbor on March 18, 2013. Only a few ships in the world could carry the load. It arrived in Seattle on April 2nd in 41 pieces. Crews spent 4 months reassembling it in an 80 by 400-foot launch pit near the city's sports stadiums in the Sodo district. The machine was named by school children across Washington state. They chose Bertha, after Bertha Knight Landis, Seattle's first female mayor, who served from 1926 to 1928. On July 30, 2013, Bertha started digging. Over 5,000 spectators and Governor Jay Inslee attended the launch. The plan called for 14 months of boring, with completion by late 2014, and the tunnel opening to traffic by December 2015. For the first 4 months, Bertha worked as designed. It averaged about 35 feet per day. Curved precast concrete segments were installed behind the machine as it advanced, forming rings that became the tunnel's exterior walls. A laser guidance system kept the machine on course. By early December 2013, the crew was optimistic. On December 3, 2013, Bertha had its best day ever. 52 feet of advance, 8 tunnel rings installed. The machine was running perfectly. Then on December 6, 2013, it was not. Metal fragments started appearing in the conveyor system. Bertha's cutter head had hit something it couldn't grind through. The rotation continued, but it stopped engaging soil. Investigation revealed the obstruction was an 8-inch diameter, 119-foot-long steel well casing. The pipe had been installed by WSDOT contractors in 2002, 1 year after the Nisqually earthquake, to monitor groundwater conditions in the same area where the tunnel would eventually be built. The pipe's location appeared in reference materials provided to bidding contractors. 589 groundwater monitoring wells existed downtown. Nearly all were made of PVC plastic. This one was steel. Nobody flagged the difference. STP assumed it had been removed. WSDOT thought so too. It hadn't. The steel pipe pushed 6 feet above street level as Bertha shoved it upward. Crews initially believed the damage was limited to the cutting blades. They expected a quick repair. They were wrong. In early February 2014, as engineers prepared to resume operations, they discovered the machine was overheating. The main bearing seal system was damaged, causing the bearing to fail during operation. The seal damage may have predated the pipe strike. During initial testing in Japan, the seal assembly had been damaged and required repairs. Hitachi Zosen later insisted the machine was delivered in perfect condition. WSDOT said an 8-inch pipe couldn't possibly cripple a 57-foot machine. STP said it absolutely did. The three parties would argue about this in court for years, but the immediate problem was simpler. Bertha was stuck 60 feet underground and couldn't be fixed in place. The only option was to dig down to the machine. Starting in October 2014, crews began excavating a 120-foot deep access pit from the street above. The work was slow and dangerous. Groundwater pumping required to keep the pit dry caused visible sinking of nearby South King Street and damaged surrounding buildings. Once the pit reached its full depth, the 4 million-pound front end of the machine, including the cutter head, was hoisted to the surface on March 31, 2015. Hitachi Zosen engineers then disassembled, inspected, and rebuilt the entire front section. Over 100 tons of new steel were added. Drive gears were replaced. The seal system was redesigned. 70,000 hours of engineering work went into the repair. The rebuilt front end was lowered back into the pit in a 4-lift process beginning in August 2015. On December 22, 2015 at 12:30 a.m., Bertha moved again. 1.5 feet through sand poured into the recovery pit. By January 6, 2016, it broke through the concrete access vault and started digging through normal soil, 2 years and 16 days after it stopped. But the problems were not over. 6 days later, a barge carrying excavated dirt tipped over in Elliott Bay, spilling soil into Puget Sound and damaging a Port of Seattle dock. The same day, a sinkhole opened 35 feet north of the access pit. Governor Inslee ordered drilling stopped again. 6 more weeks of delay. Bertha finally resumed full-time boring in late February 2016. From there, the machine worked, slowly, steadily. It passed beneath 154 buildings. It crossed under the Alaskan Way Viaduct itself, the structure it was built to replace, coming within 15 feet of the viaduct's foundations without causing measurable surface movement. Over 4,000 monitoring devices tracked ground conditions along the route in real time. In March 2017, the crew discovered Bertha had drifted 6 inches off course. They corrected it. On April 4, 2017, Bertha broke through into the disassembly pit near the Space Needle, 9,270 feet, 1,426 concrete rings, 900,000 cubic yards of soil removed from beneath a major American city. The tunnel was finished, but the lawsuits were just starting. STP sued WSDOT for $480 million, claiming the pipe was an undisclosed site condition that caused the breakdown. WSDOT countersued, arguing STP knew the pipe's location and that Bertha's design was inherently flawed. Hitachi Zosen was sued by STP's insurers, who claimed the machine's capabilities were inadequate for the project. A dispute review board ruled WSDOT should have done more to warn about the pipe, but made no finding on whether the pipe caused the damage. The city of Seattle sued both the state and STP over damage to water infrastructure. Total cost overruns exceeded $200 million. The question of who pays has never been fully resolved. All of this over a pipe installed by the same government agency that commissioned the tunnel. By August 2017, Bertha was fully disassembled and removed from the receiving pit. Practically none of its components were reusable. The 57.5-foot cutter head was cut into sections and hauled to a local steel recycler. Hitachi Zosen donated a few cutting tools and the control panel to Seattle's Museum of History and Industry. The rest was melted down. An $80 million machine reduced to scrap. Workers spent the next 22 months building a double-deck highway inside the tunnel. On February 4, 2019, the State Route 99 tunnel opened to traffic. The Alaskan Way Viaduct was closed permanently 3 weeks earlier. Demolition began in February, and by late 2019, the last section of the 65-year-old elevated freeway was gone. 240 million pounds of concrete recycled, 15 million pounds of rebar reclaimed. 9 acres of waterfront returned to the city. Bertha was not a failed machine. It finished the job. Every foot of tunnel was bored. Every ring was placed. The tunnel carries traffic today, but it arrived 3 years late and hundreds of millions of dollars over budget. The largest tunnel boring machine ever built was stopped for 2 years by a steel pipe thinner than a dinner plate. The pipe was installed by the agency that ordered the tunnel. Its location was in the paperwork. Nobody removed it. Nobody checked whether it was plastic or steel. The machine that was supposed to prove that American cities could build large bore tunnels instead became a cautionary tale about what happens when the biggest machine in the world meets the smallest oversight in the plan. If this is the kind of story you're here for, subscribe. We cover the machines that worked, failed, or quietly disappeared. The engineering was real, and the economics told a different story. More coming soon.